Hey guys, I hope you all are doing good. In this lecture, we will be covering what is a logical argument, and we will understand something very important, which is the rules of inference, right? So these rules are going to be extremely important to solve questions. But first, let's start with what is a logical argument, right? So an argument in logic is a sequence of statements where the premises or the assumptions lead to a conclusion, right? So let's try to understand what are we trying to say, right? Look, the basic idea is I have some points, right? I have some premises or assumptions that I make. Using those assumptions, I want to come to a conclusion, right? I'll try to give a basic example. Let's say I want to say 1 plus 1 equal 2. This is something that I want to prove, right? So what I'm going to do is I'm going to say, okay, 1 is a value which is equal to 1. And this is the addition sign, right? This is just a basic example that I'm trying to explain, right? I'm using the addition sign, and then when I add the 1, using these two values, we know for a fact that when we add these two values, they should result in a 2, right? Just a basic explanation that I'm trying to make in English. This is the understanding that I would try to explain to somebody who doesn't understand how this works, right? So my basic point is that I'm trying to make assumptions, right? And using those assumptions, I'm trying to prove some things or come to a conclusion, right? So that is what we call a logical argument. I'll give a lot of examples so it will make things a lot more clear on how these things work, right? Okay, moving on. Let's try to understand this very important point, right? It is valid if the conclusion logically follows from the premises. Look, the very basic point to understand is that we need to make sure that whatever arguments that we make, they are true and they follow in a flow, right? It's not that I make an incorrect logical argument throughout the way. That is what I'm trying to say, right? So we need to make sure that whatever arguments we make are actually true and they follow each other in the correct way. That is, they are not contradicting each other in the statement, right? Okay, so I hope you were able to understand what is a logical argument. Now, in order to basically go or form these assumptions and then lead them to conclusion, we use the rules of inference, right? So these rules are very simple to understand. I'll explain all those rules in a very good detail, and then we will solve some questions based on it. Hey guys, so I've written all the rules on the board. They might kind of seem complicated, but to be honest, they're very simple to understand. So I'll try to explain the logic behind each and every rule using the truth tables, right? Before you start, you might not understand this representation. So let's try to understand this representation first, right? So I'm using this representation because you might encounter it throughout your university, or maybe even if you're studying using some kind of a resource, right? So let's try to understand what this means. If you first take a look at it, it might seem very similar to how we calculate things, right? On hand. So let's say it's kind of similar to when I need to add two values, right? This is kind of the way we do it. So this is kind of a very similar representation, but let's try to understand the logic behind this representation, right? Very important to understand that you have a clear idea of what this entire representation means, right? So if you have a clear idea what it means, then it should make things a lot more clearer. Look, the basic idea is, this is about the logical argument, right? When I use this representation, what I'm trying to say is, right, I'm trying to say that if P is true and negation and P then Q is also true, then the conclusion should be Q is true, right? So let's try to understand how this is a logical argument, right? What I'm trying to say is P is true. I'm assuming that P is true, and I'm also assuming that P then Q is true. Then the conclusion from these two assumptions that I've made should be that Q is also true, right? So I hope you're able to understand it. Now let's try to represent this using the symbols that we know. The basic idea is, this is how we represent it, right? I'm saying if P is true, if we do a if with all the premises that we have with the and with each other, right? So P and P then Q. So this is the left hand side of my equation. If P and P then Q, right? If P and P then Q, then the conclusion should be Q. And if you solve this using the truth table, then you'll find out that this is actually a tautology. Now, let's try to understand what we are saying, right? I'm saying if I make the assumption P is true, and if I also make the assumption that P then Q is also true, then the conclusion should be Q is also true, right? I'll try to logically explain how this law works. So let's try to use the truth tables that we have. Okay. Let's say I have P, Q, P then Q, right? Okay. So when both the values are true, and P then Q is true, if P is true and Q is false, then this should be false. If P is false and Q is true, then this should be true, and last case this should be true as well. Now let's try to understand using the truth tables why this law works, or why does this law even exist in the first place, right? So let's try to understand. I make the assumption that P is true, right? So if you look at the truth table, let's try to break this down, or let's try to remove all the points where P is false, right? So in the assumption P is true, I only have these two cases, right? Only these two cases should be valid. Now I make another assumption that P then Q is also true. Now, if I look at this table where P is true and P then Q is also true, then I'm only left with this single portion of the table, right? So I hope you're able to understand it, right? Look, the assumption was if P is true and P then Q is also true, so I formed the table and I tried to find, or I should say, isolate the actual truth table point that satisfies this condition, right? So over here, this point satisfies it, and look at the conclusion that we form. P is true, P then Q is also true, and in this case, Q is also true. And that is exactly the conclusion that we formed, right? The basic idea is whatever assumptions we make, you need to understand that we are assuming they're all true, and the conclusion is also true, right? So I hope you're able to understand how the modus ponens works. In very simple words, I'm saying if the premise is true, or if the left hand side is true, or my assumption is true, and the P then Q is also true, then the conclusion should also be true, right? I'll try to give a very simple basic English example. So let's say it rains today. I should say it is and P then Q is if it rains, then will drop. Okay. So let's try to understand. I'm saying P if, let's say this is true, right? It is raining today. And I'm saying P then Q is if it rains today, then the temperature will drop. So let's try to understand it. I say if P is true, that means it's raining today. And I also say that if it rains, then the temperature will drop. So my final conclusion will be temperature will drop, right? So I hope you're able to understand how this works. So we have covered modus ponens, right? Once again, the basic idea, I hope you're able to understand how this entire representation works, right? We are assuming that this entire, all the premises and the conclusion that we have, we are assuming that to be true, and then the conclusion is also true, right? Okay, and this is actually entirely a if-then statement. Okay, moving on, let's try to understand the modus ponens. Once again, let's try to understand this with the truth table that we have. Right, so I'm going to write the truth values once again. Okay, so try to understand what the representation means, right? I'm saying if P then Q is true and negation of Q is also true, then that implies that negation of P is true, right? Let's try to understand this with the truth table that we have. If P then Q is true, then if you look at this table, right, I have three different parts or three different points where P then Q is true, right? This one, and the first one, right? Okay. So I know that in fact this is not the point that I need to understand at this point. Second one, I say that negation of Q is also true. So if negation of Q is true, then you need to understand that Q is supposed to be false, right? If negation of Q is equal to true, then Q is equal to false, right? Okay. So let's take a look at all those points that we have been trying to figure out or isolate. In these 3 points, what are the points where Q is false? So what I find is that there's only one point where Q is false, right? What is the conclusion that I get? The negation of P should also be true. What does that mean? If negation of P is true, that means P is false. And that is exactly the conclusion that we get in this case as well, right? So I hope you're able to understand how this works using the truth table. But in very simple English, what I'm trying to say is, if P then Q is true, and if P is false, then, oh sorry, if I say P then Q is true, and negation of Q, that means the conclusion or the implication that I'm making is false, then this side or the left hand side should also be false, right? Okay, so these two are very easy rules to understand. Moving on, let's try to understand the hypothetical syllogism part. Okay, hypothetical syllogism is another very easy rule to understand. What we can compare this rule is simply to an equation like this. If I say 1 equal x plus 2 and x plus 2 equal y plus 3. So if I say 1 equal x plus 2 and I say x plus 2 is equal to y plus 3, then the conclusion I can make is that 1 is also equal to y plus 3, right? I hope you're able to understand how this works. This is kind of exactly like how the hypothetical syllogism works, right? Okay, so what I'm trying to say is, if I say P then Q is true, right, and I also consider that Q then R is also true, then that should mean that P implies R should also be true, right? Very basic rule to understand. And I would like you guys to form a task, or I would like you guys to use the truth tables and understand how this works, right? So I think it would be a good exercise to do on your own. Okay, moving on. Let's try to understand the disjunctive syllogism, right? Okay, according to disjunctive syllogism, I consider if P or Q is true and negation of P is also true, then the conclusion should be that Q is also true. Let's try to understand this once again. Okay, if you remember, when I talk about a OR statement, this basically means that I only want one of the values to be true, right? So if I say P or Q is true, what this means is that there are three possible cases in this value, right? Either both the values are true, right? The premises or the argument that I'm making is P or Q is true. This is the assumption that I make. What that assumption logically means is that it is possible that P is true or Q is true, or maybe both these values are true, right? Now, another argument that we make in this case, or another assumption that we made, is negation of P is true. If negation of P is true, then if you try to understand it, that means P is going to be false. So now I know that P or Q is true, but if P is false, then what does that mean, right? P or Q is true, but P is false, then that simply means that Q is true, right? That's the conclusion that we can make. Once again, we know that whenever a P or Q statement is true, then it has to be three cases. Either this P is true, or the Q is true, or maybe both of them values are true, right? Now, in the assumption that we made, we already made clear that negation of P is true. That means the P value is actually false, right? So what that implies is that if P is false, then it has to be that this Q is true for this entire logical statement to be true, right? So we have understood modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism, right? Now let's try to understand the addition part. Okay, what is addition? So what I'm saying is, I'm saying if P is true, then P or Q should also be true, right? If you try to understand it, I'm basically adding a value, right? Okay, let's try to understand this with an example. So if I say P is equal to, and let's say right, just a very basic example. I know it's not a very good example, but just for explanation purposes. So how addition works is, if I am assuming that P is true, right, which is, I'm saying that he is a good boy, right? When I use a or statement, I know for a fact that I only need one true value, right? So it doesn't matter if the Q is true or false or not. I care as long as this value is true. So my assumption was P is true. That means I can add as many propositions as I want in this case, right? So if he's a good boy is true and Q he's a bad boy, then P or Q would be he is a good boy or a bad. So the basic idea is P or Q is going to be true. Why? Because I already know that P is true, right? He's a good boy or a bad boy. The basic thing to understand is that I'm using the or here. That means either the left or the right proposition can be true, right? So once again, let's try to understand the addition one more time. Assumption is P is true. So I can add any propositions as much as I want in this or case, and that will result in a true, right? So what I'm trying to say is true or false, doesn't matter how many values I do. If there's even a single true, then the entire result is going to be equivalent to true, right? Okay, so that's exactly how addition works. Okay, now let's try to understand the simplification part. Okay, what is simplification again? Look, I hope you understand the simple fact that in all these representations, just a quick reminder once again, we are making the assumption. You need to understand that we are considering all these premises and the conclusion to be true. So we are keeping in mind that this is true, and this is true. And that is how we are solving all the questions that we have, right? So now let's try to understand simplification, right? My assumption is P and Q is true. So let's try to understand my assumption. If I say P and Q is true, whenever I'm using a and, right? In the and, I always want all the propositions combined to be true, right? If even there's a one false proposition, then my entire proposition is going to be false, or entire result is going to be false. But in this assumption, I'm saying that P and Q is true. So the basic point that I understand is that P should be true and Q should be also be true. So that is exactly the conclusion in this case, right? I'm saying if P and Q is true, then the conclusion is P is true. And the conclusion could also be that Q is true, right? So both are possible conclusions in simplification case. Okay, now let's try to understand the conjunction. Okay, I'm saying if P is true and Q is also true, then P and Q should also be true. Then I think this one should be very easy to understand. If P is true, Q is true, then I can add both of them and the and value should also be true, right? Just a basic thing to understand. So we have covered addition, simplification, and conjunction. Moving on, let's try to understand the resolution. Okay, this is going to be a bit tricky to understand, but I'll try to make it as easy as possible. So let's try to understand it, right? My assumption is P or Q is true, and I'm saying negation of P or R is also true. Let's try to understand what this means, right? P or Q is true, then there are three possible cases. Either P is true, Q is false, maybe P is false, Q is true, or maybe both are true, right? These are the three cases. But one thing that I need to understand is one of them has to be true. Okay, moving on, let's try to look at the second premises that I have. I'm saying negation of P or R is also true. Now let's try to understand it, right? Okay, in the first one, P or Q was true. In the second one, negation of P or R is also true. So let's try to understand it. Let's say P is actually, in fact, true. So in this case, true or Q, right? This is exactly what I get. But in the second case, what I get is false or R, right? That is what I get. So in this case, I don't know the value of Q, I don't know the value of R, but what I understand is that true or Q is there, but when I do false or R in this case, right, that is also resulting in true. So that means if P is true, then R has to be true. P is true, then R is true, right? I don't know about Q right now, right? Maybe it is true or maybe it is false, right? Now let's take a look at the second case. What if P was false? If P is false, then false or Q and true or R. Now in this case, when P is false, then I know that false or Q, this in this case, if this is true, then Q has to be true as well, right? So if P is false, then Q is true. I hope you're able to understand what I'm saying, right? So what I'm saying is P can have only one of the two values, which is true or false. But since in this premises or in this argument that we are making, we are saying both these equations or logical arguments are true. What that conclusion leads to is that whether P is true or whether P is false, the conclusion should be Q or R. Any of these two values should be true, right? So just like we looked at the examples, if P is true, then R is going to be true. I don't know about Q in this case, but when P is false, then Q is true. That is for a fact that we know, right? From the assumptions that we have made. I don't know about R in this case, right? But the conclusion is that either way, one of the two values, which is Q or R, this entire argument has to be true, right? Okay. So hope you were able to understand all these rules in detail, right? If you have any doubt, then I would highly suggest you can leave me a feedback or I can make explanations once again in detail. But I would highly suggest that you rewind this video or slow it down, watch it multiple times, and I think it will make things a lot more clear, right? Now, if you have a good idea about all these laws, then this is going to be very important to the next place when we are going to be solving questions on it, right? Okay, now I'll be giving a bunch of questions, right? We'll take a look at examples first, and then we will be solving a few questions. Hey guys, so now let's take a look at this example, right? We have been given the premises and we need to prove that the final conclusion is refunds will be issued, right? So just like we covered, we are going to be using the laws, all the rules of inference, right? And using those rules of inference, we will logically try to reach this conclusion, right? Which is that refunds will be issued. We need to make sure that we don't misuse any law or we don't make our own rule of inference and try to use it, right? So we need to make sure that we are following the entire order correctly and we don't make any mistakes in the order, right? Okay, so the first thing is I've been given this premise and I need to understand or figure out this conclusion. The very first thing I need to do is I need to represent this all these premises using logical statements, right? So what I'm going to do is I need to figure out each premise and then try to figure out what is the logical equivalent of it. Let's take a look at the first statement in this case, right? Warehouse is understaffed and the delivery truck is late. So if you look at this statement, right, whenever I need to figure out or see a premise, I need to figure out how many propositions are there and what is the logical connectivity, right? Is it some kind of a conjunction? Is it a disjunction? Maybe there is a if-then statement in it. And then using that, I need to figure out or break it down into further propositions that I have, right? So let's take a look at this. Warehouse is understaffed and the delivery truck is late, right? I need to look for symbols such as and, or, if then, and if and only if type of statements, right? In this case, I see an and in between, right? Since there's an and, that means this is a combination of two or more propositions, right? So warehouse is understaffed and the delivery truck is late. I only see one and in this between or one symbol. That means these are the two propositions, right? This is one and this is two, right? Let's say this is negation of P, or I should say negation of A, and then this is B in this case, right? Okay, I can also say that this is negation of B. So let's first try to understand why I have denoted this using a negation rather than just maybe A or B. Look, the basic idea what remains is that we always try to show the negative statements using the negation, right? So for example, let's say I say he is a bad person, since this is kind of a negative statement, then I'll try to use the negation sign to represent that proposition, right? And the positive would be that he is a good boy, right? So in this case, warehouse is understaffed is kind of like a negative statement, and that is why I'm representing it using a negation of A, right? This is just a basic way to do it. Obviously, we can choose the other way around, but this kind of makes this a rule in your mind and you understand how exactly the flow is working, right? So what I've done is I can represent this as the negation of A, a proposition negation of A, and this as a negation of B. So this entire premise, right, logically, that means negation of A and negation of B, right? So I've represented the first premise using a logical connective, right, which is negation of A and negation of B. Moving on, let's try to understand. So I see the statement, if packages ship today, then warehouse is stopped. So let me ask you this question, right? Do you think that this is a single proposition, or do you think it's a combination of multiple propositions, right? So the answer is that this is actually a combination of multiple propositions. And why? I see a if then statement, right? And whenever there's a if then statement, that means there's a combination of a proposition, right? So the propositions are this packages shipped today and warehouse is stopped. Okay. Now, how do I represent it, right? Do you think I should represent packages shipped today maybe as a proposition C, and maybe I can represent this as proposition B? But I don't think this is the right way to do it. And the reason is I already have a proposition warehouse is understaffed, which is negation of A. Warehouse is staffed would basically be A itself, right? So I'll represent this as A in this case. These are basically the same propositions, but they are the negations of each other. So if packages ship today, then the warehouse is staffed. How do I represent it? I'll basically say C, then A. I hope that makes sense, right? So I'll try to write down these arrows as well to represent what I'm doing. I'll also explain why I'm leaving this gap in between, right? Okay. Now we have if packages do not ship today, then the customer will be notified, right? Once again, there are two propositions, packages do not ship today and customer will be notified, right? How do I represent it? I already have a representation for packages shipped today. So packages do not ship today would just be the negation of it, right? So this is going to be, I can represent this customer will be notified. Since this is a new proposition that I don't see so far, I'll represent it using a letter D. So what is going to be the final premise itself? It is going to be if packages do not ship today, that is negation of C, then customer will be notified, which is D. Right? I hope you're able to understand it. Now we have if the customer is notified, then the refunds will be issued. Right? So once again, customer is notified, refunds will be issued. So customer is notified, I already have it. So since this is going to be D again, and I can represent the final one, refunds will be issued as E. So finally, I get D to E. So this was just the first part of my entire solution, right? I represented each premise, I figured out each premise, tried to separate it or represent it using the symbols, but that involves figuring out what are the propositions and what are the symbols being used, right? Figured that out, I've represented all these propositions using the symbols, right? So this basically completes almost 50% of the answer. Now we need to prove that refunds will be issued, and we will use the rules of inference for this, right? So I'll give you a step-by-step instruction on how we solve these type of questions. Let's start with a look at the first premise, right? Always remember that you need to start with the first premise and follow along the way. How do we do it? Step one, take a look at the premise and try to find conclusions from that premise, right? I need to figure out any conclusions that I can using the rules of inference that I already know. So I see negation of A and negation of B is true, right? What are the conclusions that I can form, right? If this is true, that means negation of A is true, negation of B is also true, right? since the negation of A and negation of B is true, that means this both these propositions have to be also be true, right? So my conclusion is, in this premise, it is negation of A, negation of B. These are the two conclusions that I form. I don't see any other conclusion that I can form in this case, right? Simple conclusion is negation of A is true and negation of B is true. Basically means A and B are false, right? So once again, what is the rule of inference that I use? This is going to be simplification. Okay, moving on. Okay, now this is the premise. I figured out the conclusions. Now it's time for me to move on, right? I don't see any other conclusions that I can form. So hence I'm moving down to the next one. So this is C to A. And what I'm supposed to do is whenever you are moving in the flow, try to use the conclusions that you made from the previous premises, right? That's the entire goal. You're gonna take a look at premise, form conclusions, use those conclusions to solve the next premise, right? So in this case, these are the conclusions that I have, and this is that I'm looking at, right? This is the premise that I'm looking at. I see that there's a negation of A is true, and C then A is also true. Now, if you remember, there's a rule for it, right? And that rule is modus tollens, right? Which basically says if P then Q and negation of Q, then negation of P. This is the modus tollens rule. So in this case, I know negation of A is true. C then A is also true. That means negation of C is the conclusion that I get, right? Right. So you can take a look at other conclusions that it can form, but I think this is the only one conclusion that we form, right? So what I did is I used the conclusions from the previous premise, used them to solve this one, and figured out that that means negation of C is also true. So far, try to understand that I'm logically solving this equation, following each and every rule that we are supposed to use, right? Okay. So what is this rule again? This is going to be modus tollens. Okay, now negation of C is true. I'm going to use this conclusion for this premise in this case, right? Negation of C is true. Negation of C, then D is also true. And this is a very simple law to understand. That means conclusion would be D. Why? Because this is the modus ponens rule. So in this case, this is the modus ponens. Okay, finally, D is true. D then E is also true. Then the conclusion should be that E is true. And this is once again going to be modus ponens. Okay, I really hope you were able to understand this question. If you have any doubts, then you can leave them in the comments. But this is the basic way we solve these type of questions. Once again, I'll give you the steps to do it, right? You're given the premises and you're given what you're supposed to find, right? The conclusion that you're supposed to find. Your first task should be to convert it into logical statements, right? For example, represent this using the symbols, each and every one. Second, leave some gaps in between those premises that you have. Now, starting from the first one, find any conclusions that you can find using the laws, write them down, and then use those conclusions to solve the next one. And keep flowing in this way until you have found the final conclusion that you're supposed to find, right? It is also the case that maybe you might be having to use a previous conclusion. For example, I might have to use a conclusion which I figured out in the first premise to use in the last one, right? So that is also the case. So the best way is write down the conclusions for each and every one and then try to figure out which conclusion that I should be using, right? So I hope you were able to solve this question. Now I'll be giving a bunch of questions for you guys to solve, and then we will move on to the next lecture. Okay, so for this video, I'm only giving you 2 questions, right? The video is getting way longer than I expected, so I just thought I'll give lesser questions. And if you guys want, I'll add a few more questions in the comment section, right? So let's start with question number 1. Identify the flawed step in the proof, right? So it says if the code compiles, then it passes the test. The code compiles the test, right? And the conclusion is that code compiles. Let's try to understand it. The first thing is I need to figure out what is the logical equivalent of it, right? maybe represent it using the symbols and the letters, right? So if the code compiles, this can be one proposition, right? It passes the test, can be another. So let's say this is P and this is Q, right? Code compiles, it passes the test. Both are kind of positive statements, so maybe I'll just represent them as if P then Q. It says the code passes the test, that means it is Q in this case, and the conclusion they form is P. What do you think is the mistake over here? Let's try to understand it, right? If P then Q, Q is true, then the conclusion says P should also be true. Let's try to compare it to the truth table, right? So I have P, Q, P, then Q, right? When both are true, then this is supposed to be true. When P is true, Q is false, then this is supposed to be false. If this is false and this is true, then this is supposed to be true. And if both are false, it's going to be true once again. So let's try to understand what is the flaw. It says P then Q is true. That means it's one of these three cases, right? And it says Q is also true, right? What are the cases where Q is true? It is this one and this one. But take a look at this. It is forming the conclusion that P should also be true. But if you take a look at both these examples, right? P can be true, right? Even though Q and P then Q are true, it is possible that P is false and P is true, right? So we cannot form this conclusion. That means this is incorrect. So this is actually not a law. What we can do instead is, if this was P, right, then I can form the conclusion that Q is true, right? So this is the flaw in this case. This is an invalid expression and we cannot do this. Look, you're not supposed to figure out whether the statement in general is true or not, right? That's not what we are trying to do. What we are trying to do is, it doesn't matter if the statement is true or not. We need to figure out whether the logic flow, the assumptions, they follow a logical flow and reach out the conclusion, right? In this case, that's not the truth, and that is why it is going to be a flawed operation, right? So hence the flaw is that it can be P then Q, but if Q is true, that doesn't necessarily mean that P is going to be true. Okay, moving on. Question number 2, using these premises, prove negation of S, right? So in this case, you don't have to form symbols. I've already given you the symbols, right? So first I have negation of P, and then E implies P and S implies E, right? I need to form the conclusion that negation of S is true. So just like the steps, what I'm supposed to do is, I've been given negation of P and E then P is true. From these two, my conclusion would be that negation of E is true, right? And this is going to be the modus tollens. Okay, so modus tollens, and now negation of E is true. S then E is true. That means negation of S is also true. And this is modus tollens once again, right? So I hope you were able to understand this question. Once again, in these type of questions, you need to take a look at all the premises that you have, form all the conclusions, and then try to figure out if there's any new conclusions you can find, right? Usually what happens is that it logically flows from the top to the bottom, but it is possible that you might have to use the conclusions used in one premise in the last one, or maybe the conclusion in the last premise to use in the first one, right? But the basic idea is represent them, find conclusions, try to compare them, and figure out any rules you can use. So I hope you were able to understand this lecture, and in the next lecture we will be understanding proofs, right? So I'll see you guys in the next lecture.